Hey guys, I'm here to help you out with future values and present values today. We're going to review just a little bit. We're going to talk about like what is the difference between future and present values. Figure out what would you rather invest in or what would you rather have. Your homework is the quiz, and there's four problems on Classroom. Put those in as a private comment this week. There's an easy way for me to look at them as a private comment. Yes, I understand it's the opposite of what I told you previously. We all are learning and making mistakes. Um, by the end of this lesson, hopefully you should be able to know what's the future value of a dollar and what is the present value of a dollar and how we calculate those things. A really common misconception for people is that if somebody gives you $100 in a year from now, how much would you be willing to pay for that? Well, you're not going to give somebody $100 today to get $100 for in a year from now. Like that $100, like there's a cost associated with that. First off, there's inflation. You can invest it in something else. You could always get that $100 later. The longer you have to invest your money, the higher the return you expect. And vice versa, if somebody says, I'm going to give you $100 in the future, what is that worth? What's the present value of that today? So today, this lesson isn't really complicated. It's not a math lesson, it's a calculator lesson. It's a picking out parts lesson. And so I'm going to have to use Screencast-O-Matic here because I want to show you guys how to use the calculator that I've given you online. So the question is, if we invest $2,000 a day, what will it be worth in 5 years if we earn 15% interest compounded monthly? Or if we invest $4,000 a day, what will it be worth in 5 years if we earn 8% interest compounded quarterly? Which one would you rather have? Do you know? You can guess right now, but these are the types of decisions that businesses have to make all the time. And there's a really easy way for businesses to look at this and for you to calculate this. And again, this isn't a math class. Like there is a math formula. I can show you guys. I'm going to show you guys the formula, but you don't need to know that. The hard part about these things is picking out which piece is which and applying it appropriately. So some things for you to realize. And if I were you guys, I would like pause the video here and write these down. So if FV stands for future value, PV stands for present value. We don't write out future value and present value. C is the number of compoundings per year. So if something compounded quarterly, 4 quarters make up a year, so that's four. Monthly, 12. You can even do this by the second. It's pretty crazy. R is the annual interest rate. N is the total number of compoundings. And so you have to do the number of compoundings in a year times the number of years to get that. So if you did it quarterly for 5 years, that's 20 compoundings. So N would equal 20. And then we use AN for annuity. We're not doing any annuities today. We'll do that next week. But just something to talk about or know. So this is the website that is super valuable. I'm going to post this when I post this video. This is the one you should go through. This is the future value of savings. If you go in the investing time value of money, everything's right there. It's a super great place to look. So the first thing we're going to look at is what is the future value of a dollar? So what is a dollar going to grow to in the future? So if we invest $2,000 today, and what is it going to be worth in 5 years if we have 8% interest compounded quarterly? So how do we figure that out? What do we do? So you need to figure out what are all the different pieces. So that's going back to the little thing that I showed you previously, the previous slide of, where is that stupid slide? This one. This slide of the time value of money components and figuring out these different things. So $2,000 is the present value. Our interest rate is 8%. It's compounded quarterly, so 4. and it's for 5 years. So 4 compoundings a year times 5 years is 20 compoundings. The annuity is 0, so like we're not putting any extra money into it. And so the future value of that is $2,971.81. Well, how do you get to that? This is the formula right here. Present value times $1 plus the rate divided by the number of compoundings a year raised to the number of compoundings equals the future value. That's a relatively complicated way of doing it. What I would recommend doing is if you go to the website that I gave you, and I'm going to slide this over so it's more split screeny if my mouse goes through with me. So we're trying to figure out the future value. So we have the present value, which is $2,000. There is no payment, which is 0. The period interest rate. So this is where it messes people up. You're looking for the interest rate for the time period. People always want to use this 8%. That is the annual rate. This is a period rate that we're looking at here. And so what we want to do is we want to go by and divide that 8% by the number of periods. So that's 2% times the number of compoundings is 20. So that's $2,971.89. If I messed up and I didn't divide that 8% by into the number of interest per period instead of I did an annual rate, you can look and see how much that changes it by substantially. It goes all the way up to 9,000. So you really need to make sure that you divide the rate by the compounding period. So if it's compounded yearly, then that's a yearly number. If it's compounded monthly, we would divide that 8% by 12. So however many compoundings are, that annual rate gets divided by that yearly compounding number. We already talked about that. So would you rather, if we had to invest $2,000 today, what would it be worth in 5 years if we compounded that 15% compounded monthly? Or if we invest $4,000 today, what will it be worth in 5 years if we have 8% interest compounded quarterly? So again, all this is simply identifying the different pieces. We have a present value of 2,000. We have 5 years compounded monthly, so 5 times 12 is going to be the total number of compoundings. We have a yearly interest rate of 15, and so when we put in the calculator, you're not going to put in 15 because that's a yearly rate. What we need is a monthly rate. So we're going to have this 12 divided by 15, and that's the interest rate we're going to put in. Same down here. We have a present value of 4,000, 5 years, compounded quarterly, so it's going to be 20 compoundings for that's the N. 8% interest compounded quarterly, so it's 8 is the yearly number. We need that to be a quarterly number, so we're going to divide that by 4. If we flip that to the present value of $1, we can use a future dollar amount to figure out how much we should pay for it today. So if we say we're going to get $2,000 in 5 years, what's it worth today? You would think it would be worth close to $2,000, but it depends. And again, this goes back to using our calculator here. And it just kind of does the exact same thing, we just move it. So we have a future value of $2,000. We have no payment. We're not getting any money beforehand or putting any money in. Our interest rate for the time period. So it's 8% for the year compounded quarterly. So what's 8 divided by 4? That's 2. We have 4 quarters times 5 years, so that's 20 compoundings. And the result is we would want to pay $1,345.94 for that in the future. So I know exactly how much I should pay for that $2,000 today based on everything. Um, Again, if you want to do this by hand, you can. It's not that difficult. You just need to make sure that you're really focusing on making sure that you're using the right interest rate. For this, it does it for you. It's that R divided by the compounding rate. If you're using it for or the calculator, you have to make sure you're using the period interest rate, not the annual interest rate, the period interest rate. If you use this formula, it's an annual interest rate. So, big takeaways here. You need to understand that future values and present values change. Like something is not going to be worth the same today as it is tomorrow. And there's always going to be an interest rate that's associated with that. You can use these calculators that are available online to do this extremely quickly and accurately. The big hang up here, the big thing that people always screw up is they mess up. Are they trying to figure out the future value or the present value? If you're trying to figure out what money in the future is worth today, that's present value. If you're trying to figure out what money today is going to be worth in the future, that's future value. Also, another thing that people screw up is when they're using the calculator, they take that period interest rate. You need to take an annual rate and divide it by the number of compoundings per year. So if you have an annual rate, and you're doing it daily, it has to be divided by 365. If you're doing it monthly, it has to be divided by 12, and if you're doing it quarterly, it has to be divided by 4. You can always figure that out that way. But if you're going to do this, make sure you use a period interest rate and not simply just an annual rate. If you guys have any other questions, let me know. I'm going to wish you guys good luck and tell you to do your